Welcome back to Unit 2, Section 5, or Chapter 5, Section 5-7. This is the fundamental theorem of algebra. Sounds awful important, so make sure you take really good notes. Although everything we do is important, right? After completing the lesson, you'll be able to use the equation of a polynomial to identify the number of solutions there are in a given polynomial equation. That's both real and imaginary. Find the solutions to a given polynomial equation. Write an equation for a polynomial in standard form given all of the zeros, and approximate the zeros of a polynomial function by graphing the function. This one you're probably going to practice this last one in class tomorrow using the graphing calculator. We've kind of done that already, so this is one we're just going to touch on again. There'll be some problems in your homework, or should be, excuse me, your in-class work tomorrow. Okay, so what is the fundamental theorem of algebra? It basically tells you how many solutions you're going to have in a polynomial. And it's, I think, one of the easier theorems that we have. If you have a polynomial with degree n, then you have n solutions. So let's take a look at that. Example, f of x equals x to the fourth plus 15x squared minus 16. So degree n. What is the degree of f of x equals x to the fourth plus 15x squared minus 16? Well, degree means highest exponent. What's the biggest exponent we have in this problem? Pretty self-explanatory. It looks like 4. So our degree is 4. So we have 4 solutions. Now, they're not all real solutions. They're not all even rational solutions. They could be imaginary solutions, there could be irrational solutions, but there will be 4 solutions to the problem. There might be some that are repeated solutions, and we'll talk about that as well. If not on the slide or in notes say in class tomorrow. F of x equals negative x to the 12 plus 6x to 7 plus 3x to the 5th plus 2x plus 8. Well, the degree is, that's right, it's 12. And that means there are 12 solutions. And like I said, doesn't mean they're all real, doesn't mean they're repeated solutions. Okay, so you may not be able to see them all on your graphing calculator when you graph the equation, but there are indeed 12 solutions to that equation. So that's how we use it. That's what we're going to use it for, to figure out how many solutions we have. So now that we have the fundamental theorem of algebra, we can use it to predict how many solutions we're going to have when it says find the zeros. So if it says find all the zeros of the polynomial function, our degree is 4. So that tells us we're going to have 4 solutions. Okay, 4 solutions to this equation. So let's go about it. So how do we want to solve it? Can we, we can do P over Q. We might be able to factor it. It's in quadratic form. But we could do P over Q if you'd like. Our P over Q, P is factors of, the P values come from factors of A sub 0, which is 16. So 1, 2, 4, 8, and 16. I think I missed any there. And then factors of the leading coefficient, A sub n, that's going to be 1. So that means our possible rational zeros are 1, 2, 4, 8, and 16. So let's go to the graphing calculator. Let's put this equation in. X to the 4th plus 15x. So if you go back and this one like that, it's second delete. I'll let you insert something in this. 15x squared minus 16. And let's graph it. See what we get here. So it looks like we have some zeros that are popping up. Let's go to the table. Find at least 1 here. Looks like 1 is a 0. We'll find the others. Maybe we got, well, at least we get 1 0, right? We get negative 1 and 1. So it looks like from our graph, 1 and negative 1 are zeros. So that helps us because now we can use synthetic division. So we have 1x to the fourth plus 0x to the third, plus 15x squared plus minus 16. That's an unboxed number. They skipped over the cube, so we have to put a 0 in. And now we just pick a 0, 1 or negative 1. I'm going to pick negative 1. If you want to do positive 1, that's fine. So 1 comes down. 1 times negative 1 is negative 1. Negative 1 plus 0 is negative 1. Negative 1 times negative 1 is positive 1. 16 times negative 1 is 16. 16. Oops. I missed a term, didn't I? Aha. What was the other term I missed? I missed 0x. I wondered why that wasn't working. I went so fast, I thought I was so good that I thought that first 0, I missed the other one. So I was because see it wasn't going to line up correctly and get a 0 as a remainder, so I knew I must have missed a term. So I have to put a 0 in there. Okay, so back at it, we get negative 16 here. Negative 16 times negative 1, that's better. Positive 16, which gives me a remainder of 0. So if negative 1 is a 0, x plus 1 is a factor. So 1x, in this case cubed, minus 1x squared plus 16. X minus 16 is another factor. What do we do now? That doesn't look good. That doesn't look like something that's going to work out so nice. Well, what we can do is we can do synthetic division one more time with this polynomial. 1x cubed minus 1x squared plus 16 minus 16. And we'll use the other 0 that we have, which was positive 1. If it was a 0 of the original polynomial, it's a 0 of this one. Bring the 1 down. 1 times 1. 1 times, put 1 there. 1, negative 1 and 1 is 0. 1 times 0 is 0. 16 plus 0 is 16. 16 times 1 is 16. Remainder of 0. So now we have x plus 1 from before. And if 1 is a 0, then x minus 1 is a factor. 1x squared plus 16. So, I can't factor x squared plus 16. It's not a difference of squares. But since there's no x term in there, I can set it equal to 0 to solve. Remember, we're trying to find all the zeros. So, x plus 1 equals 0. X minus 1 equals 0. X squared plus 16 equals 0. Subtract 16. We get x squared equals negative 16. We square root both sides. Uh-oh. We have to square root a negative number. So let's pull the I out. Won't hurt at all. Square root of 16 is 4. So, plus or minus 4i. Over here, these are the more straightforward ones. X equals 1. We already knew those. Subtract 1. X equals negative 1. We got those answers already. 1 plus or minus 4. So the solutions are negative 1, positive 1, negative 4i, and positive 4i. And we would never get the negative 4i and positive 4i from the graph. We could only get those by factoring it out. Now you could have gone up here and factored the original problem, I think bottoms up style. This is in quadratic form. So if you tried that, that should work as well. And you should get the same solutions. You should factor it out to get this result right here, x plus 1, x minus 1, x squared plus 16. And then you just continue on the same way. Okay, so that is factoring and using the zeros to factor it, and then using zeros from the rational zero theorem to factor, and then finding imaginary solutions at the end. Okay, our last task for today, or in this section, is to write a polynomial function with least degree that has a leading coefficient of 1 with negative 1, 2, and 4 as zeros. That sounds like a mouthful to me. But there's 3 zeros. So if we kind of use the fundamental theorem of algebra, we should end up with an x to the third power polynomial. There's 3 zeros, are those the only 3? Then that's what it has to be. Can't be anything else. So how do we use this information? Well, we say f of x or y, doesn't matter either one, equals x, well, plus 1. negative 1 is a 0, and x plus 1 is a factor. X minus 2, because positive 2 is a 0, so x minus 2 has to be a factor. And x minus 4, because positive 4 is a 0. Now that is a polynomial function of least degree, but it's factored. Okay, so when they say this, what they want you to do is they want you to multiply it out. So this is review of FOILing. So x plus 1, we can't multiply all three at the same time, so we just got to FOIL 2 at a time. So when I FOIL this through and line up my terms, I end up with x squared minus x minus 2. And I still have this x minus 4 over here that I haven't multiplied. So now I got to multiply again. You can try the FOILing like method again. Once it gets to trinomials, I like to just do the table. So if I don't do the table on the first step, that's okay. But the second step, I suggest it, especially if you're somebody that makes little mistakes on FOILing. The bigger the polynomial, the harder it is to FOIL it. X squared times x is x cubed. X times negative x is negative x squared. X times negative 2 is negative 2x. Negative 4x squared. Positive 4x. And positive 8. So I line these terms up and then add them together. X cubed by itself minus 5x squared plus 2x and 8 is by itself as well. Here is my equation. F of x equals x cubed minus 5x squared plus 2x plus 8. We are going to do some in class tomorrow that deal with imaginary zeros and complex zeros using conjugates. So, continue on, or wrapping up the lesson. I believe we did use the equation of polynomial to find the number of zeros that are in a given polynomial equation, i.e. the fundamental theorem of algebra. And we found the solutions to a given equation. And then we wrote an equation given the zeros. We have not approximated the zeros of polynomial by graphing specifically in the material presented just now, but we will do that tomorrow in class, and we have done it previously as well. So bring your notes with you tomorrow. We'll check them off, and we'll do some more practice in class. Have a good day.